Welcome back for the next set of problems where we're going to be looking at incline planes. Okay, so I'm adding to my formula sheet page, and two formulas that I want to point out come from math class. Slope is the ratio of rise to run. So whether you do a big rise and a big run, kind of a bigger step along this line, or a smaller step, the ratio of the rise and run, these have to be perpendicular, will be equal. So it doesn't matter how big the rise and run. You can do a big step, little step, they're always going to equal the same ratio. So that's slope, just a reminder, rise over run. And then the other thing, when we're dealing with incline planes, often, right, we're dealing with a vertical change. We're using the incline plane to get an object to a new height, or maybe down from a height. But we are dealing with a vertical distance of height. And then we're dealing with this horizontal distance of over what horizontal distance does our ramp kind of take up space. We could call that the base of the ramp, how far out from maybe the step the ramp extends, however they might describe that, but that's that horizontal distance. Well, that horizontal distance that represents kind of the base of the ramp and the height, the vertical distance, with the ramp then make a right triangle. And so Pythagorean theorem is the theorem used to find a missing side of a right triangle. A and B are the legs of a right triangle, so they have to be the base and the height. It really doesn't matter which one's A and B. Addition is commutative, but the ramp is the hypotenuse. It is across from the 90-degree angle, and so your actual incline plane or the ramp, make sure that goes in the C spot. But these are formulas we're going to be using. So let's take a look here at the handout. First one just says to sketch and annotate the picture. And so we've got a civil engineer must design a wheelchair accessible ramp next to a set of steps leading up to a building. The height from the ground to the top of the stairs is 2 feet. Based on ADA, it's Americans with Disabilities Act codes, the slope must be 1/12 or less, and slope is equal to the rise of the ramp divided by the run. So they do remind you of that. Okay, so we've got a 2-foot elevation due to stairs and a slope of 1/12. So let's draw this. These are incline planes. At 2 feet is probably 3 stairs. Something like that. And so we're trying to get up this distance, and they're saying if you're going to lay down a wheelchair ramp, the slope of this ramp needs to be 1/12 at the most. And that hopefully makes sense because a person in a wheelchair, if it's too steep, they're going to start rolling backwards. Now, the slope, 1/12, that's rise and run, right? So that's equal to rise over run. Well, they've already told me that these stairs are 2 feet tall. Okay, remember, slope is just the ratio of the rise to run. It doesn't tell us what the actual rise is in our circumstance. It's just the ratio. So very well probably has been reduced, right? So if we want to solve for the run, well, I'm getting ahead of myself, right? Because all they did is ask me to sketch and annotate. But this base here, that distance, we can solve for that, the ratio of rise and run here. We just need to figure out what number is going to make that become 1/12. And that might be the next problem. Let's look. Using the ADA code, what is the allowable minimum length of the ramp base? It is. Okay, so the minimum distance of the ramp base is this distance right here. It also kind of represents how far out from that top stair, from that top corner, horizontally, this ramp is going to have to extend. Okay, and so our slope of 1/12 has to be equal to our height over, I'm going to use B for base. And if we solve this, this is really just a proportion. We've got equal fractions, so we can say the diagonal products are equal. 1 times B is B, has to be equal to 2 times 12, so that's 24. And you can go double check it, right? Does 2 over 24 become a 12? It does. Alright, so that is the minimum distance. if you don't extend that ramp out to 24 feet, it comes any closer, then the ratio of rise to run is going to be greater than 12, then the ramp's going to be steeper, and it's going to make it too difficult for some people using their wheelchairs. Alright, number 20. Using the known height and calculated base length, what is the length of the slope of the ramp? So what is the length of the actual ramp? Alright, so maybe I'm the carpenter who's going to go build this thing, and so I now understand where on the ground this ramp is going to come out to. I understand where it's going, but the actual length, I need to construct this with materials. I need to understand how many materials I need. So I want to calculate that length. Well, that is just the hypotenuse of a right triangle with legs of 2 and 24 we found out. So what question is this? This is 20. We're on number 20. So we would simply do 2 squared plus 24 squared equals the ramp. Can I just do r squared? That color's probably not showing up very good, is it? So 2 squared plus 24 squared equals r squared. Alright, doing the Pythagorean theorem, you're going to square the numbers. 24 times 24. I think it's 576. Let's double check that. 24 times 24. Yep. So then you would combine like terms. They just so happen to be on the same side, so just 580. We don't have to add or subtract from both sides quite yet. But what you would do is you would isolate the variable that's squared, and then once it's isolated and you've simplified the other side, we got to get rid of the square because we want r, the ramp. We don't want r squared. To get rid of a square, you simply take the square root of both sides, but you got to have it simplified. Alright, so the square root of r squared becomes r, and then we need the square root of 580, which is going to be just a hair over 24, right? 24 point, let's see, we can add 4, and then hit the square root button right here. 24.08, so let's just round to the nearest tenth, so 24.1. So it really is not much longer than the length that the base is the ramp's gonna extend out horizontally, but that is the length of the actual ramp is just a hair over 24 feet. Let's see, is there any more questions? Yep. Okay, they ask, what is the ideal mechanical advantage of the ramp? So 21. IMA. Okay, so IMA is dE over dr. What is dE? dE is this distance that the effort, the person or thing providing the effort, it's the path that they take. And the path that they are going to take is to travel the ramp. Oh, I'm sorry, I'm not on the camera. Okay, so it's dE over dr, it's IMA. And so dE, I was saying, is the length of the ramp. That's the actual distance that they travel through space as they follow the ramp. Okay, and then dr is really the distance we wanted to travel. What we really wanted to do is simply get elevated 2 feet. That was the resistance that we're trying to overcome, is this change in height. So we will say that IMA is the 24.1. I know that's a rounded value, but I'm going to use that, and the dr was 2. So that's going to become 12.05 approximately is my mechanical advantage. And there was one more question. 22 says, if a person in a wheelchair have a combined weight of 185 pounds, so that would be the resistance that we're trying to move, is that total weight of 185 pounds. It says, how much ideal effort force is required to go up the ramp? Again, this is how much ideal effort force. So they're giving us permission here, right? We generally say that the ratio of the forces, because they're giving us an FR, and they're asking for FE. We say that the ratio of those is equal to the actual mechanical advantage, but we don't know what the actual mechanical advantage is. Okay, they didn't tell it to us, and we don't have both forces to calculate it. And really the amount of friction that you would have is probably going to be variable from one wheelchair to the next, and depending on how heavy the person and wheelchair are combined might create even more friction. So anyway, they are giving us permission. They're saying best case scenario. Ideally, right? They use the word ideally. So that said, go ahead and use your calculated IMA to find that force. And we know that that's the best case scenario. So we're going to use that 12.05 as our mechanical advantage in solving for FE. All right. Now that 12.05 is really a 12.05 over 1. And so this is, again, this is a proportion where we can cross multiply. So I can say that FE times 12.05 is equal to 185 times 1, which is 185. We're going to then come back and divide both sides by 12.05. To get our required effort force, at least the best possible. So that's going to be 185 divided by the 12.05. So about 15 1/3. There you go. All right, that was through 22. Next up is the wedge.